emerging professional.
Nanotechnology involves the manipulation of objects that are at the nanoscale for a desired application. What we're interested in is trying to understand and detect human disease through the use of new and fascinating nanotechnology. So the nanoscale covers a range from 1 nanometer to 100 nanometers, and that's really small. So if you think about a human hair, it has a diameter of about 100,000 nanometers. So we're talking about manipulation of really small things. A rapid disease detector will be able to detect a human disease very quickly at the patient point of care. Particularly in developing nation settings, the faster you can diagnose someone, the faster they can get treated. It's better for everyone, not just the individual, but for their whole community. Right now, for this device, we're interested in tuberculosis, malaria, and HIV. This is a benchtop version, so we would ideally get it much smaller to be about the size of a television remote. What we have is a chip, which is inside of our vial, and the vial contains our sample, say urine, and the chip is modified using nanotechnology. It's a little complicated, but there's nanoparticles there, there's DNA there. All of this combines to pick up and select only the target biomarkers for the disease state. So for example, if this is urine from a patient with tuberculosis, then we're screening for certain markers that we know only TB patients would have. And the instrument uses a laser to collect a chemical fingerprint from the sensor surface to tell us whether or not that patient does or does not have tuberculosis. Right now in South Africa, it takes anywhere between 4 and 16 weeks to get a TB diagnosis, which is way too long. We're in year 2 of a 3-year phase, and we were approached by a group of people who are interested in really working towards helping people in developing nation settings. My hope for the future is that we can move nanotechnology forward to really make this a better world for everyone.
I think that alternative fuel is important for several reasons. We're looking at being able to reduce countries' dependence on foreign fuels, reductions in greenhouse gases and a higher energy output when they're burned. And in addition, the overall process for actually developing and producing biofuels and alternative fuels typically is more sustainable, and also that has a much more minimal impact on the ecosystems. Algal-based biofuels are basically a drop-in replacement for petroleum-based fuels. And when I say drop-in, I mean that most of the engines today can actually burn the biofuel without being heavily modified. There are probably 3 main benefits for algal-derived biofuels. The first is that when we're cultivating algal biofuels, we can actually use waste CO2 and waste nutrients as a feed for the algae. So not only can we contribute to waste processing and disposal, but we actually get an additional product out of it. The second benefit would be that farming algae actually requires significantly less land than other sources of biofuel like corn, jatropha, canola. And in addition to that, we can actually use land that's not suitable for the agricultural industry, so we negate the food fuel dilemma. The third reason would probably be that after the oil is extracted from the algae, all of the leftover algal biomass can actually go into a really wide variety of different products, everything from animal feed to agricultural fertilizer. So the waste generated by this process is very minimal. I think I began my research because of the fascination and the curiosity that I've always had with nature. I've always marveled at how elegant and complex it is, yet at the same time how simple it is. I mean, it's streamlined, it's persistent, it's sexy, it's beautiful. In 2007, I started studying the polar regions, and from that, I started realizing that as my research started to unfold, it became more apparent just how devastating the impacts humans were having on ecosystems like the Arctic. As a result of this, I started to become frustrated and really driven, and it became apparent to me that my research wasn't enough and that I actually needed to do something. In 2010, I founded SABRTech under the name of the Marine Arctic and Antarctic Technologies Incorporated. We're integrating algae into the industrial thinking of organizations and governments around the world to create a new form of industry that works with nature to achieve economic progress. My hope for the future is really that humans can find a way to align themselves with nature, to stop exploiting resources, to find a way to work with natural systems to achieve economic and societal progress.
People are often surprised to know that engineers have anything to do with water treatment. They think that it might be a chemist. The significance of studying water quality is clearly that people need water to survive. If you think about water coming from the source, which could be an open lake, and going through treatment and into the distribution system and finally to the taps, that you have to make sure that when someone opens their tap that they're getting clean, safe drinking water. You can tell in those areas where there isn't safe, clean drinking water that the impacts are massive, whether it's through waterborne diseases or if people are taking most of their day to access clean water, having to walk for miles in order to get it. That, of course, impacts their education and their other activities that they might be involved in. The World Health Organization attributed about 88% of deaths from diarrhea to waterborne diseases. So we're really lucky when we have the ability to study water quality and make sure that it's safe. It's never a one-size-fits-all. Every water is very different. There's different chemistry, there's different physical properties, different biological properties, different piping systems in the ground, different treatment systems. So there's hardly ever a time where one solution is going to be applicable across the board. I like to focus on small-scale systems because they have limited resources in terms of access to research and access to financial resources. The City of Toronto would have access to research basically that will be able to optimize their systems and have it down literally to a science, whereas in a system like Wolfville, there's 4,000 residents. That's a small-scale system. The smaller operations, when they come into some sort of issue, they might not have the ability and they simply don't have the income from the lower amount of residents that are purchasing the water. So that's where I'm hoping to aim my research. The numbers of girls in engineering is low compared to even other sciences. So it's great for me to be able to put a face on engineering for girls and for them to be able to identify with me and see somebody that looks like them, and that helps them imagine that they could do the same thing essentially. My hope for my research is that I make a contribution, whether it's in a new technology being developed or it's in just a new practice that is implemented into drinking water treatment. To make water a little bit safer to drink and make it easier for those utilities to deliver the water.